Okay, we are live.
All right.
Let's see. Hey, Hank, I'm going to go ahead and promote you to panelist. Keith, good to see you. We're going to get started in just like a minute. I'm going to mute. Okay, it is 5 o'clock and let's just go ahead and get started.
Okay, we'll roll. All right. Well, hello, everybody. We glad to have you out tonight. This is a professional development that we're working on that we're going to be presenting for over the course of the next few weeks on eclipses in preparation for a couple of eclipses that are coming. One on October 14th and one on April 8th. So this is aimed primarily at educators, both formal classroom educators as well as informal educators. But really anybody's welcome, of course. We are here at Slooh, so it's great to have you here. Keith, it's good to see you. You're welcome to unmute and show video if you like, but you don't have. There's no pressure to. So. And Hank, yes, we don't want you, if you're driving, we don't want you being distracted at all. So anyway, great to have you both here. What I'm going to be doing is sort of walking through a professional development module that this one's focused on the upcoming eclipse, the October 14th eclipse, but it'll touch on other eclipses as well. And there'll be some takeaways from this particular presentation, some activities, some things to do on Slooh. And, one of the things that we're offering is professional development hours. So showing up to being a part of this presentation. And also when you doing some outside work as well, some quest work, which, that ties in and deepens our understanding of concepts, you'll get a certificate at the end of this. And I'll talk more about that as we get into things. But I will be also sharing out some activities, some presentations you can use with your students or with your groups, whatever groups those might be. You're welcome to use the presentations. You're welcome to take them and make them your own as well. So you'll get copies of these presentations and then you can make your own copy and adjust as necessary. So just a quick note of introduction. My name is Russ Glenn. I'm currently teaching 6th grade science and 7th grade coding and robotics at St. Stephen's Episcopal School here in Austin, Texas. And once upon a time, I worked with Slooh full time, and now I work part time, mostly with professional development and consulting on anything that sort of regards education. I love Slooh. We'll have a lot of fun on it, as I think we all do, and certainly see it as such a great avenue for students. And that's one of the things I'm going to talk a lot about today is sort of how, in a classroom, we want to, utilize Slooh and utilize other activities and models that help us to enable our students and deepen their understanding. I'm going to go ahead and share my screen, and then we'll kind of jump into the presentation. If you want to say anything, I'd love for this to be a little interactive. I do have an interactive piece. It may not work we have kind of a small audience tonight, so the interactive piece may not work so well tonight, but that's okay. And we'll go on from there. So I'm going to mute for just a moment and stop my video, and I'm going to pull up my screen. So I'll be right back. All right, so one thing that I love to do whenever I'm presenting with Slooh or working with Slooh with my students is I like to start things off with planning some missions using our accounts. So if you have access to your account, you can pop on over and plan a mission or two or all of your missions. I do this a lot with my students because it becomes a habit for them, which I think is really important in astronomy, is for us to make it a habit so that we see, if we're planning missions every day, we're seeing how things might be changing. Some things change from our perspective, some things don't, obviously. But it does give them some idea of the seasonality of space and how some things are visible at some certain times of the year and some things are not. So, if you haven't already done so, you can pop over and plan some missions using your Slooh account. I'm recommending a lunar mission if you haven't planned one in a while, just because we will be talking about the moon today as well as the sun. We can't plan any solar missions. We have to go to the live telescope and during the day and watch those and capture some images there. So go ahead and plan a mission or two, and I'm going to advance our slide and sort of give us an idea about what's coming up next. So today's professional development module is focused on the 2023 annular solar eclipse. And, this is going to touch on a lot of the Western states in the full annularity, which we'll talk about in a little bit. But really everywhere in the United States is going to see a partial eclipse at least. It's kind of great that it's happening on a Saturday. So a lot of people will have a chance to go out and see it. This module is here to help you out with planning for that. And also with maybe understanding some new concepts if you are new to eclipses. We all come from different backgrounds and different knowledge bases. Hopefully this will help you understand eclipses a little bit better. I'll also talk a little bit about historical perspectives. And as I mentioned, there'll be a couple of presentations that I'll share with our participants. And they can use those presentations in their classrooms or use those presentations in their informal education settings. So, the first part I have here is a little bit of how are you today kind of thing. I'm not sure if we'll have if we'll have any energy to share how we're doing today, but if you're willing to share how you're doing today, I picked a bunch of objects, and I like to do this with my students. Kind of pick some random objects. Maybe they're all in the same category or something. You can use space objects. You can use other objects. But it's a nice way for us to get to know each other a little bit. How are we doing today? Are we, are you feeling like one of these nebulae? Are you feeling like a galaxy, the moon, globular cluster, that's the Hercules, or maybe Jupiter? And oftentimes the more important piece of this is, well, why are we feeling that way? Why did we pick that particular object? So I always ask that question. And I'm going to start, and then we'll see if anyone else wants to jump in and share. They can. You don't have to. I'm perfectly okay just being the talker here. But today I'm feeling a little bit like the moon, I would say, and I'll tell you why. It's been a fun week, but it's also been a really busy week, and so I'm feeling a little bit. It's also Wednesday, middle of the work week. Obviously, I work with middle schoolers, so sometimes by this time of the week, we're feeling a little bit pitted and cratered with mostly all the questions that I get every day. We're doing an inquiry lab in my classroom, and I get a lot of questions from kids about how to plan their experiments, which are wonderful, but can also take a little bit out of you, or out of me. So that's how I'm feeling today. Is anybody willing to chime in and let us know how they're feeling from this list of images? Any of our small group that we have going here? I'll do a little 3, 2, 1, and then we'll move on. Okay, 3, 2, 1. All right. So anyway, this is something you can do too with the people that you work with. It's sometimes fun to get to know them in a different way because they might share. You take some objects. Maybe you take a bunch of insects. What kind of insect are you feeling like today? And see how they're feeling. Of course, tonight I picked astronomical objects, and I encourage that always. So, all right, let's move on in our presentation. This professional development is really envisioned as a 4-module professional development. So you can kind of see a little bit about what is going to be included with each of the module. Each module, there's 4 of them in the next few weeks. This will probably be repeated in the future, perhaps with a slightly different focus at the beginning, since the annular eclipse will have passed. But so each module is going to have a little bit of a different focus. Today, we're going to talk about the science of eclipses in general. I'll talk about some historical significance, although it's relatively brief, the historical significance that I'll discuss today. We'll add some more. And we'll talk a lot about the upcoming annular eclipse. It's really important, I think, to plan in advance for these kinds of things, especially because you might need some materials. I'm going to be talking about some Slooh quests that are really great and focused on these kinds of concepts. I'll give you some hands-on activities that you can do for your classroom or your group, and also that you'll eventually get the pre-made presentations. I'll share those with you as well. You can see step number 3, it's part of the professional development piece of this is that we want you to do some outside work. We're offering a 16-hour professional development piece and so looking at doing 3 new quests, hopefully ones that deepen your understanding of the material that we're working on. So maybe, and I'm going to share with you a list of those quests. I'll show it to you, and then you'll also get a copy of it with quick links to all the quests that you might choose to do to deepen your understanding of eclipses. A lot of what I'm talking about, though, is how do we prepare for these kinds of things? I'm an educator lifelong, and what I want to enjoy the course. I just want to prepare, and especially this one that's on Saturday, they're not necessarily have a teacher right there next to them helping them out. Perhaps in April, it's on a Monday, and so perhaps they'll have a teacher there with them, but not necessarily. So let's move on. Sort of the quick basics of an eclipse. What we're going to be talking about and focusing on are solar eclipses in these modules, but having an understanding of lunar eclipses is really important as well. They're more common, in a lot of ways easier to view because they are visible from larger areas of the planet, whereas solar eclipses are a little more geographically specific in where we find them. So, a solar eclipse is when the moon comes directly between the Earth and the sun, so that its shadow actually falls on our planet. So in a way, it's very simple. It's the sun. It's the sun's light being blocked by the moon. So it's a shadow, just like any shadow that you might cast as you're walking down the street on a sunny day. So in some ways, it's really simple. It's not that common, and we'll talk about that in a little bit, but it's a very simple concept. It's just a shadow. But when we think about space, light and shadow have huge ramifications for planets and for moons and things like that. So even though it's a very simple concept, it actually has big ramifications. That's a solar eclipse. A lunar eclipse is when the Earth comes between the moon and the sun so that the Earth's shadow covers the moon. And, we're going to see a scale model in just a little bit of the Earth and the moon. One of my favorite models, easy to make and has a multitude of uses, but we'll see a scale model of that. So we'll see. We all probably know the Earth is bigger than the moon. How much bigger? Well, we'll find out exactly how much bigger. And then we'll also see how we can sort of model these eclipses using a very simple instrument and a really great one for the classroom. Pretty simple. This is what eclipses are. They're shadows, but they're big shadows, and they're very exciting, and they have a pretty important place in a historical context, which we'll talk about in a little bit. So here's a fun word, syzygy. Love this word. It'd be a great one for Scrabble or Words with Friends or something like that. But when celestial objects line up, we call it a syzygy. So, it doesn't mean they're lined up in a certain way. They just have to be in a line. And when we get a syzygy, we can get an eclipse. This can be any objects. You can certainly see eclipses on other planets and things like that too. So if there's a moon orbiting another planet, it can be eclipsed or eclipse the sun. So we get this lineup, this thing called a syzygy, and as I mentioned before, it really matters what object's in the middle. So during a solar eclipse, we got the moon in the middle, and during a lunar eclipse, we get the Earth in the middle. Now, when we look at the eclipse that's coming in October here, this is a nice map, and I'll direct you to some resources as well for further, looking deeper into this particular eclipse. But, this is a map of where we're going to see what's called annularity. So, this is an annular eclipse, and we'll talk about what's the difference between annular and a total eclipse in just a moment. But that big stripe down that you see right here, going from Oregon down to the Gulf of Mexico, that's the stripe of the part of the country, that the band of the country that's going to see the annular eclipse. This is sometimes called the Ring of Fire eclipse. So it's doesn't cover the sun's disk entirely. There will be some of the sun visible, but this is the area that's going to see that. Now, outside of that band, you're still going to see an eclipse. It's just going to be a partial eclipse, and you can see some of they give you some details on that on this map. I'll show you where to find this map. There's a really great resource out there that some of you might be familiar with, but if you're not, it'll be a nice thing for you to have access to. All right. To get an idea sort of how this eclipse is going to pass over the country, there's a nice video animation here that I'm going to show. I think it's only a minute long, or maybe even shorter. Just shows you how the shadow is going to actually pass over the parts of the Earth that are in that particular band. So let's take a quick look at this. It's only a minute long. And for those of you who might be lucky enough to be in that band, well, you're going to get a very cool event, a Ring of Fire eclipse. For those of us who are not in that band, we'll see a partial eclipse. So still an amazing event. And, this is a big moment for them. We've had one in October, and then another one in April, and then we won't have another solar eclipse for many years in the United States. You can kind of see, you've got to make sure you're in the right place at the right time here. But, this is a nice little animation that shows you this path of the sun. Now, there's lots of great animations out there, and I'll show you another resource where you can find some nice animations. Whoops, I didn't mean to start it again. I'm trying to get out of here. There we go. Okay. I'm going to digress for just a moment and talk a little bit about models and phenomena, and the difference between them, the importance of both. As a teacher, oftentimes in the classroom, we're using models because phenomena can be really hard to see in the classroom, right? You're waiting for something to happen, especially astronomical phenomena. Your timing is middle of the day, and so it's difficult to actually for kids to experience a phenomena. But which is one reason why I think that Slooh is such an amazing resource, is that it enables students to actually see phenomena, not have to just look at models. Now, models do have their place, and a couple of things I'm going to show you today are models that I think are really valuable, but coupled with viewing an actual phenomena. So it's really important for kids to have that experience with that. So for this particular event coming up on the 14th, we as educators need to start talking about it, getting our kids excited about it. And that's why, we're doing this at this moment. We have about a month, a little bit less than a month. But you can get kids excited about it. You can help them plan for it. They're going to need help, probably from their parents, with getting to, the right location, or making sure they have the right materials so that they're safe when they're watching this particular phenomena. So this is a really unique opportunity. It would be great in some ways if it was during a school day, because it's right in the middle of the school day. It'd be wonderful, but that's not, it's not going to happen this year because it's on a Saturday. So encouraging students to get out and observe this annular eclipse. And I'm going to give you I'm going to show you a presentation, and it'll be one you can have that you can actually show to your students. That'll hopefully get them excited and give them some tips on what they need to do to prepare. Also, though, Slooh has some really great resources, including, which another thing I'll show you included with the presentation is Slooh is also going to have Slooh's lead astronomer, Paul Cox, is going to be leading star party for the annular eclipse. So that's another thing that, even if they can't get out and see it, they can still be a part of it through that star party, or maybe do both, be out there seeing it if they can, while watching the star party on their phone. There's no reason why they can't do that and be a part of things. So, phenomena are great, and we need to have our kids experience those as much as possible, because those are the things that really lead, I think, the kids to the questioning that might lead to some scientific discoveries for them. But typically in the classroom, we're limited to a lot more models, especially from an astronomy perspective. So I'm going to show you a couple models. I think models are really valuable, but they always have strengths and weaknesses. And I think it's really important when we're talking about models with students to help them build their critical thinking skills by thinking about what are the strengths of this model, what are the weaknesses of this model. How is this model helpful? How might this model be a little bit misleading in some way? So I think, and that's really building that critical thinking piece that is, it's so hard to build, but that's one way to draw it out of them, is you teach them, you show them a concept, you show them a model, and then you say, well, what's valuable about this model? Or better yet, have them write it down so that they're all thinking, not just one student sharing out loud. So I think whenever you show a model, get the kids thinking about it. And I'm going to show you a couple of models that you'll have access to after this presentation. I'll share with you the materials, and then we'll certainly circle back to Slooh, because Slooh is a great way to, first of all, they have tons of great models, but they also have access to the actual phenomena. It's a wonderful thing for students to have access to those phenomena. So I'm going to start with this particular model. One thing that we can't observe in the classroom. You can see some images that will help us, but there's, to actually observe solar system formation would be impossible. So, there's a set of cards that I'm going to share a PDF with you. You can print it out. And these cards go through the formation of the solar system. And so I think this is a unique opportunity, right? We're talking about an eclipse, but to have an eclipse, you've got to have a sun, and you've got to have an Earth, and you've got to have a moon. So it's a really unique opportunity to investigate with your students the ingredients for this particular eclipse. Now, these cards, here's 3 cards. There's 9 cards total. I'm going to show you all of them. But these cards, the way you use these cards, give the kids a set of cards. Have them work with a small group. They could work individually too, I suppose, but a small group is really nice for this. And you have them try to put them in order as they think this for solar system formation. So you tell them up front, hey, these cards are about the solar system forming. Try to put them in order. So the kids have all these cards out in front of them. There is a little written description for each of these on the back of the card. For you, you're going to get a set of a PDF that's going to have each as a separate page. So you could give them the descriptions later, which I think would be really nice. You can also purchase these cards online, but I think they work just as well as a PDF. So the kids try to put these in order. So, they get all these cards, and it's great. Even if they don't know anything, they're using their skills of observation. They're starting to see, the little details that are popping out on the cards. They might be looking at the scale at the bottom. They might be looking at the temperature gauges, and even if they don't know the Kelvin scale, they're going to get an idea about this. It's really about the thinking. So you let them go through and you let them puzzle it out, and create their own, pattern with these 9 different cards. And then as a class, you could go over it together and say, okay, what did we discover here? Like what actually happened? And there's a nice segue on this card right here, the accretion part, to actually talking about the formation of the moon, if you want to get into that. But this is a really great way, I think, to model solar system formation, a visual way, and also a manipulative way. So the kids are moving it around. And it gets them thinking. There's a lot of great videos out there that show how the solar system formed. Well, that's great. They can watch that. But this way, they're actually thinking about it themselves and how did it form. So I wouldn't lead with a video, any kind of video. I always try to lead with activities that makes a child think, builds those neural pathways to becoming better critical thinkers, and certainly in science, better observers. So, these, let me go back to the start here. We have a lot of clues here, right, that the kids might start to pick up on. So there's a scale clue on the bottom here. This is our first card, just our large nebula. And then they might notice this, goes to 200 AU. They might not know what an AU is. You can share that with them. There's no reason they shouldn't know what an AU is. But even if they don't know, they might realize, oh, something's happening at the bottom here, these cards. Now, they might not know what a light year is, so that might be a little misleading, right? So again, we're starting to have these things that we can talk about later when we're debriefing this activity. Like, you saw 28 LY. What did that mean? They're like, I don't know what that meant. They didn't know it meant light year, or maybe they did. Who knows? But those are all really great ways to get them thinking critically about information, which I think is such an important part of what we do as teachers. Okay, sorry. There, I hit the scroll bar, and it started zipping through. So I think one thing that you can use this opportunity, this eclipse, and this might get the kids a little more excited, is to talk about how did the solar system actually form? These cards are a really great way to do it. And as I mentioned, each card has a description on the back. So these could be, you can print these out for each of your students. They could each have their own set with the information. And, there's a lot of information here, and there's a lot of depth you can go into here, but you don't necessarily need to go into all the depth, depending on the age group of your students, depending on the class that you're teaching. Even if you're teaching an astronomy class, well, that's one thing. But I work with 6th graders, I'm teaching life science. I'm still going to do this with them to get them excited about the solar system and to get them excited about this upcoming eclipse, right? And give them a deeper understanding so that when they're out there, they're thinking about that. Oh, wait, we learned how the solar system formed, and I learned how the sun, heated up in the middle of this cloud and this disk to eventually become the sun. Let me see. Oops. Again, I'll get this eventually. Okay. So that's one model that I think is really valuable and that you can use. I want to introduce you to another model. And this is probably my favorite like model that I just love it. I think it's great for a bunch of reasons. One, it's perfect. It's a perfect little model. That's not very descriptive at all. Let me tell you why it's perfect. One, the kids make it, so they build the model. Two, it uses very simple ingredients, stuff that you probably have in your classroom or can get a hold of pretty readily. Three, it models a bunch of different things and can be used to model a bunch of different things. So this is a model for visualizing the Earth-Moon system. And it's also a great way for students to actually make a solar and lunar eclipse. They can actually model both of these, and they can actually use the actual sun. So they can like create their own syzygy using this model and the sun, like as their thing. Now, I don't usually tell them what we're building at first, because again, I like for them to think about it, to ask questions about it, and us to work through it. So a lot of times we'll build something without knowing what it is. And they'll say, what is it? And I'll say, what do you think it is? And they'll think about it, and, we'll do a big reveal at the end. It's always a good time for a drum roll. Kids love that stuff. Actually, adults love that stuff too, I would say. Adults are mostly just big kids. They like to have fun too. Now, you have to be careful with this one, because if you do go outside with this model and you use the sun as your light source, you're going to have students who are going to look around for the sun with their eyeballs. And that's a bad thing. So I always have to say, I always tell my teachers that I teach this to, and I tell my students, don't look at the sun. When you go outside, put your back to the sun, use the shadows to figure out how to make your eclipses, right? You don't need to look for the sun. You can find the sun by finding your own shadow. So I have to say it because inevitably students will look at the sun if given the chance. So here's this particular model. Let me show you how it's made, and then I'll show you an example of the model, and you'll see why it's so much fun too. Okay. Oops. So you're building a scale model of the Earth and the Moon, and then you can model an eclipse. So, in this description, and you'll get a copy of this too, clay or Play-Doh, pretty easy stuff to get. You can have them measure either in metric, which I prefer in the classroom, or you can use imperial units, 1.25 inches. So that's the Earth. You're building a little sphere for the Earth. You're building a sphere for the Moon, 0.8 centimeters or 8 millimeters, much more difficult to measure, but they just need to get pretty close. 1 meter or yardstick, either one will work. 3 toothpicks and 2 binder clips. Now you'll need the bigger binder clips, the ones that will attach to a meter stick. And then you can use a bright bulb to represent the sun, or take them outside and let them use the sun as their actual sun, as their model. But this is a great way to show syzygy, the way things line up, and also to show the way things don't line up. It's one of the reasons we don't have an eclipse, is because things eclipse all the time. Even as the moon orbits our planet, it's at an angle, about 5-degree angle, so it doesn't always eclipse the sun for us. So let me go ahead and let me go to the next slide. We ended up, you make the spheres and you attach the Earth and the moon to the meter stick. But I oftentimes, before I do it, I'm asking them questions or having them ask questions. I don't like to necessarily just tell them everything we're doing. Eventually, I will tell them because we need to know, but they can create true scale. But I'm going to stop sharing my screen for a moment and show you this model. And I love it. It's so simple. It's easy to build, and kids love it too. Now, it gets a lot of fun. So let me stop sharing for just a moment. And I'm going to show, I'm going to show you this model. I've got one that I built the other day, and I'll have my students build it pretty soon. So, simple materials, cheap materials. I love this kind of stuff, right? There's our Earth on 2 toothpicks and the binder clip and the meter stick. Here's our moon on 1 toothpick, the end of the meter stick on a binder clip. This is scale. This is scale, size, and distance, which is the beauty of it. So if they build it to this scale, they're actually building a scale model on a meter stick. So, they'll never look at a meter stick the same way. And they'll never look at, maybe clay the same way either. So I love these kinds of things that, maybe, even once you're done with this activity later on in life, they'll use a meter stick for something else, maybe doing some measurements, and they might even think of this activity, right, later on. Or they might be like, oh, with this object, I remember the Earth was about this big or something like that. You never know. Certainly anything the kids learn about the moon is great because they're going to see the moon their whole lives, right? And the sun. So these 2 things are really great. Anyway, that's the model. Super simple. The cool thing is, and I don't have I don't have a bright enough light, but what you do is you go outside and you put the sun at your back and you create your eclipses. You can actually eclipse the moon. This isn't fitting very well on the screen. So you can eclipse the moon, or, again, keeping the sun at your back always. You can also do your solar eclipse. You can actually see the little shadow of the moon on the Earth, the sphere that's the Earth. So it's really awesome. The sun is the best thing to use, but just remind the kids, keep the sun at your back. You're trying to create a syzygy, a lineup of celestial objects, Earth, moon, and then sun, wherever it is. Again, we can talk about some of the great things about this model and some of the bad things. Well, it doesn't work very well at night unless you do have a bright bulb, but it certainly is a great one for the school day. And the kids have a lot of fun with building this. They have a lot of fun trying to figure out what it is. And then they love making little eclipses out of it. And you can also have them do little diagrams and things like that if they're working with partners. I think the more that they can draw things and interact with things, the better. So there's my favorite model. I'm going to put this one away for now. So, 2 things that you can do with a group of, I'm saying students, of course, but it could be anybody. I mean, it doesn't have to be your students. If depends on whether you're a teacher. Or do we have any teachers here today? I don't know. Hank, I haven't met you, I don't think. Keith, I remember you. I believe you are a teacher. Is that correct? You guys can feel.
Yeah, Hank, go ahead and unmute. I think he might have stepped away.
Yeah.
I just like to share what I know, and I love exciting people. I like your approach. I like getting people to think and use their eyes and learn on their own, not to be told. Just give information and let them put it together, just like you're sharing. This is awesome. But I
For
do
sure.
not teach.
Cool.
Maybe later.
Yeah. Yeah. Well, I mean, I think there's formal teachers that, like, I go to work every day. That's my career. But then there's also informal teachers, and there's a place for everybody, especially I think in astronomy education. People love it, and we need, like, people on the street talking about it. So yeah, any Hank, you probably are a
Agreed.
teacher. You may just not be a career teacher.
Not yet, but yeah, I gotta retire out of my body work.
Yeah. Awesome. Okay, cool. Well, I'm going to head back to my presentation. I got one more model to show, and then I'll show you some of the.
And that model was awesome. What was the size of the Earth?
3.3 centimeters.
3.3, and then 8 millimeters for the moon.
And for the moon. And I'm going to share that. All this stuff is going to be shared in a Google file of some kind with you as participants. So you'll have access to everything, and you can use this however you want, even if you're just building them for yourself or whoever. All right, so yeah, so I love that model. Certainly the solar system formation model, I think, is really valuable too. Let me, okay, so whoops, let me pause this for a moment. So, one question that and I like to ask the kids again. I always ask the kids the questions first and see what they think. Although it's important if kids start going down a road of misconception, it's important to, like, say, oh, that's a great thought. However, so, talk about, like, why don't we get these eclipses every month? And I love this video because it shows how perspective plays into things. So I'm going to go ahead and hit play on this video. You can see there, this is the moon orbiting the Earth. And it's going to move into, sort of what appears to be the shadow. So why aren't we having an eclipse, or are we having an eclipse? And then, we can see that we actually have a tilt here. The moon is tilted in its orbit around the Earth. There's obviously all these gravitational wobbles going on. And we'll talk a little bit about those in a little bit, but that tilted orbit means that we don't get an eclipse every month. Let me see. Oh, I'm having a jam up here. Just a second. Let me stop sharing for a moment and see what's going on. Okay, let me pause for a moment, and I'm going to show you a couple of presentations that you can actually share with other people, or you can certainly use them all you like. One of them, though, is sort of aimed at students for getting them the information they need to enjoy the annular eclipse that's coming up. So let me go ahead and take a look at that one. Oh, actually, before I do that, I do want to show you one other model that is one that is more active. So for maybe for some younger kids, or even just kids who need to get out of the house or of the school, this would be a good one. So let me show you this particular model as well. This is more of a kinetic model, I guess you could call it. Like the kids are actually running around as the parts of the solar system formation. So this one actually probably couples really well with the cards that I showed a little while ago. This is called active accretion. Again, this is not original with me. you know, I would say none of these things are original with me. These are all things I found and curated and love and use for my classes. So, you know, this one's great because, you know, along with the cards, you can use this one, this is a whole lesson plan on it. The kids basically go outside and they each take on a role in the forming solar system. So, you know, some people might be dust, some people might be asteroids, everybody spreads out, they're all running around, tagging each other. And then, you know, they kind of accrete together. So they, you know, basically like blob tag, you know, but they're accreting together. Over, you know, once they accrete from dust, they become a chondrule, you know, they become meteoroids. I mean, it's just kind of a fun thing. So it's introducing them to some new concepts, getting them active, and also helping them see kind of how things came together in the early solar system. So let me scroll down to these images here. These are the cards you would hand out to the kids. But you can see it's pretty dense with material. So depending on what grade level you're using, you can almost any grade level can benefit from it. So you know, here's our dust grains. So you print these out. The kids would all have them. Chondrules, meteoroids, asteroids is as big as it goes. So they don't really get to planetesimals, but it's a good thing for them to start seeing how this all occurs and how small things add up to be the much bigger things. Let me pop over to a different window. And I got to move down there. Okay. So, you know, there's a few things in here that are going to be the same. This is the slideshow that you can share with students or community, even community groups or anybody really, on this great Western Ring of Fire eclipse that's coming up on the 14th. So I'm going to go ahead and full screen this one. And again, we'll walk through it. So, and you can share this out with anybody that you like. You know, if you've got a local library that's looking for a presenter about the eclipse, that would be great. Or in a classroom. So I always put this kind of thing in because especially if we're communicating with the public, they need to know that this is not a total solar eclipse. And that's a whole other thing, right? Is making sure that even people in a total solar eclipse know that there's just a small window when you can take off your glasses. But this is not a total eclipse. This is an annular eclipse. And the sun will still be bright even when it's been covered up with the moon, the shadow, even when the moon is covering it up, that it will still damage their eyes. So, you know, here's a nice graphic. This is from Slooh, one of Slooh's graphics, amazing one showing, you know, how a solar eclipse works. And you can see it's a very small area of the Earth that's affected by these. And I think that's what makes them so special, makes them so amazing, is that, you know, you're in the shadow, the moon's shadow, you know, covering up the sun, which is really cool. We'll talk a little bit about that coincidence in just a moment. But this also gives us a little bit of the vocabulary that we can use: penumbra, antumbra, umbra, and it defines all that. So this is another great thing to use with students because they're going to learn some new vocabulary, and they'll learn, you know, that they're different parts of the shadow have different names. They might not have even known that before. How many of us knew that? And how many of us know these terms? Not many. So it's a great thing for them to start learning. Again, just extending our understanding. So, you know, it's a bit of a cosmic coincidence that humans are here and able to observe this phenomena. And, you know, the cool thing is that in the sky, the moon and the sun appear almost the same size, even though the sun is 400 times wider than the moon. But it's also 400 times farther away from the Earth than the moon. So, and these are both images taken with the Slooh telescopes. Again, when I'm working with students, I'm always wanting them to actually observe the phenomena as much as possible. And Slooh is a great way to observe those, any kind of astronomical phenomena, but especially the sun and the moon are amazing. You can see changes in the lunar phases over time, which is a great thing for students to see. And you can also see changes in the surface of the sun, which is kids are amazed by that when they realize the sun is not just a static hot ball of gas. So let's talk a little bit about the geometry of this. So a solar eclipse occurs when the moon is in between the sun and the Earth, and that means that the moon is actually in what's called a new moon phase. So this is a moon you won't actually see. So you won't actually be able to see the moon when the eclipse is occurring. And as we talked about a little while ago in our sort of other presentation, this one's more for the public. You don't see an eclipse with every new moon because of the moon's tilt. Its orbit is tilted in relationship to the Earth's orbit around the sun. So in most months, the moon actually passes either north or south of the ecliptic or the sun's path. So you won't actually see this. You won't see the moon either because it's in a new moon phase. It's still invisible to us from the Earth. So the annular eclipse, what is it? We've talked about it a little bit, but not in strictly in detail. And this is a nice way to start thinking about it, is that the moon has an elliptical orbit, so its orbit varies over the course of time, and it varies by quite a bit. This is no small number of miles or kilometers. So when that eclipse occurs when the moon is farther away from the Earth, just like when something's closer to you, it appears bigger, farther away appears a little smaller. Well, the moon's going to appear a little bit smaller and not going to cover up the full disk of the sun. When it is closer, we'll get a total eclipse. But this particular one that we're getting this time around in October is going to be an annular eclipse. So the moon's not large enough to cover the full disk. We're going to see a thin band of sunlight around the edge. And that's what we an annularity or an annular eclipse or ring of fire. That's a more fun way of thinking about it too. So if you're in the narrow path, and I don't know, Hank, I don't know where you are, but hopefully you're in the narrow path. But if not, you'll still get a nice partial eclipse. But it's going to be passing through Oregon and a bunch of the western states, Nevada, Colorado, Utah, New Mexico, Texas.
I'm close to it. I'll see it.
Yeah, maybe you can drive to it.
Oregon.
Oh, okay, cool.
I'll drive down to Oregon and to the remote backcountry there, and I'll see it. Nice.
That's going to be amazing. I mean, that's going to be. I think that's where you're going to get longest annularity too, is in Oregon. I'm down in Texas. We're going to get just a little bit where I am, but still lucky to be in the path. But even if you're outside of the path, you're going to get a nice partial eclipse. I did notice, and this made me really wish I could take a road trip. It's going to pass over the Four Corners area. So I thought, how cool would it be to be standing at the Four Corners area and watching the eclipse? But I can't travel on that day, and that's okay. So. All right. I've shown this already to you all, but this is again.
Quick question. What did you mean by the longest annularity?
You're going to get a longer period of time in the with seeing the eclipse, the annular eclipse.
Okay, because this chart you have up now, it's deceiving because the yellow is the longest, it looks like, within it. And
Oh
that's
yeah,
way
you're
up.
right. You're right. Yeah. So I had it backwards in my mind. So you're correct.
I'm going to be up in the just a shorty.
A shorty. Yeah, you're right.
Hmm.
Yeah.
Bummer.
Well, come to San Antonio, I guess.
Yeah.
Yeah, no, I had it backwards in my mind. So thank you. Thanks for setting me straight. Yeah, so again, this is we've already seen this view here. Hey, that's really good. That's a good thing to remind us all to make sure to read our charts as best we can and interpret correctly what we're looking at. So thank you, Hank. Same video. We don't need to watch this one again, but this is again for showing it to a public group. I also would encourage any kind of interaction with Slooh. There's the Ring of Fire Annular Eclipse Party, which I think is hosted by Paul Cox. I'm sure he may have a special guest or two. I don't know, but certainly you can interact with other people who are interested in space. And so if you're out there watching the eclipse at the same time, you're able to chat with a bunch of a community of interested people. That's a pretty cool thing. All right, I'm going to be wrapping up here in just a little bit, but I want to show you a couple more resources that will be useful. And I want to start with this document right here. So, this document really tried to show a lot of the Slooh resources for this particular eclipse. The guides are amazing, and you'll get a copy of this. So it's just a quick click to get to any of these places. These are all the quests that relate to the sun and the moon to help deepen our understanding. I think even if they're not directly eclipse related, anytime we can deepen our understanding of the objects involved, that's a good thing. So you'll get a copy of this as well. These are a bunch of resources that Slooh has available for us. I want to jump now to the last part of the presentation, which is another presentation you're going to get a copy of. Just a quick glimpse at eclipse prediction and a little bit of the history of it. So obviously right now we just kind of take it for granted that we're going to know when an eclipse is coming and how long it's going to last. And even if you get your map turned around in your mind, the map's out there for reading. So, but that's obviously has not always been the case. Now they do occur like a clockwork, so we can predict them, and we can predict them with stunning accuracy and information, and that has developed over time. But it requires detailed knowledge of the Earth's orbit and around the sun and the moon's orbit around the Earth. And the other part of this is that it requires knowing the topography of both of these objects, which I'll address in the next professional development. We'll talk a little bit about how we got such well-developed eclipse predictions. But since both orbits are slightly elliptical, the distance between the objects changes, and when they change, it alters their orbital speed. So, even though it's like clockwork, it actually isn't, because things are actually changing. And this is, Kepler's second law of planetary motion. As the distance between the objects changes, we get a change in speed or velocity. So, the closer they are, the faster they travel, farther apart. And so there's all this interaction going on between these three objects. And so, the fact that we can predict these is pretty amazing. And the fact that we can predict them with such accuracy is astounding. Slooh has a great catalog guide on Kepler. It was written by one of our interns a few years ago. So, who was the first to predict a solar eclipse? Well, there's been a lot of possibilities of ancient cultures. They may have predicted them, although they certainly observed them. There's no clear evidence that there was prediction occurring. So observations, yes. Predictions, uncertain. So the Chinese cultures, the Mesopotamian cultures, the Central American cultures, they all observed them and they have records of them, but they don't have records of prediction. So, a story that you might hear is, an ancient Greek prediction, perhaps, which is, there was an eclipse that stopped a war. So the story goes that the Medes were battling with the Lydians, and this had been a battle that had been going on for years. And then a total solar eclipse occurred during the battle, and both sides threw down their weapons and called a truce. Now, the account of this comes from Herodotus, a Greek historian. But 100 years after the war, he said that another Greek named Thales of Miletus predicted that this eclipse would occur. At least, he says, he predicted the year in which it would occur, did not predict the specific date, but most astronomers think that that's probably not the case, that this is probably just attributing something to him. I mean, 100 years had passed. There's no clear evidence that this was predicted by, even though there's a historical account that it was. It's a much later historical account, probably not a prediction. Thales of Miletus probably did not have the tools to predict an eclipse, a solar eclipse. So probably this is more of a myth than fact. So any thought as to who might have been the first to predict eclipses? Any guesses from our group? I've given a clue here at the bottom. Any thoughts?
Hank?
What?
Hank, you're muted.
I know, Haley.
Yes. So there's the comet. That's my little clue. So I mean, yeah, there we go. It was Edmund Halley. He was the first to predict the return of a comet, which is now called Halley's Comet. And he was also the first to predict a solar eclipse. He used what were then pretty new, Newton's laws of gravity. He forecast an eclipse to cross England on the 3rd of May in 1750. Now, he published this map. He didn't want people to be afraid and to think, up until that time, eclipses had been a thing to dread. They oftentimes meant, or to the people who saw them, something bad is going to happen, usually to a king. So he drew this map up, and he let people know that nothing bad is happening. I think it was it was a King George probably at the time. I don't know who the king was. Someone else might know that, but nothing bad's going to happen. This is something we can predict. This isn't something that we don't know about. We understand these. So Edmund Halley was the first to predict. Got continued clarification from a couple of astronomers. Friedrich Bessel, he was a German working at the Königsberg Observatory, and in 1824, he devised a technique, and then that technique was updated a few years, about 30 years later, by an American astronomer who, it's during that time when people kind of did everything. He was also a maritime a guy, and he helped to found the Naval Academy. His name is William, I'm guessing Chauveneau. I don't know exactly how to pronounce that, but it looks French of them. So these are the two who really helped us to predict that. And in fact, this eclipse that's coming up, this annular eclipse, was predicted in the 1800s using using the Bessel-Chauvenot techniques or Chauvenet techniques. So while so this certainly was not predicted with the precision that we have. When they first put these together, these formulas that they came up with, they were assuming the moon was just a perfect sphere, no terrain or irregularities. So that's really what they've been working on since then to come up with better predictions. Is the moon has actually just as much difference in elevation as the Earth does, including our trenches and our Himalayas. Like there's a huge amount of variation in elevation, and that changes things from the perspective of an understanding movement of these objects. So, as our technology has increased, so has our knowledge and our ability to predict and get these things better, or our predictions better. All right, I'm gonna just show one last resource, and then we'll stop and see if there's any questions or comments or anything we want to talk about, and then we'll, if we want, we could finish up looking at some telescopes, the live telescopes, which I'm always excited to do. But I do want to show this particular resource. This is not a Slooh resource, but this is one that's really helpful. The great AmericanEclipse.com is an amazing resource for both of the upcoming eclipses. So I would certainly recommend this as a place to go. This is kind of a cool video as well, because it goes through each state, and you can see the shadow. And I guess it does, it does lengthen as it goes across the surface of the Earth. So that would be a better view down in than Texas. So Hank, again, thank you. And this is kind of a nice video just to see where it's going to go over and what it's going to look like. So I don't think we need to go through this. It's a 5-minute video, but it's one you can take a look at. But also I'm looking at the Texas page, but there's also a page for each state, and then there's also just an overview. So it's a really great resource. This great AmericanEclipse.com is a great resource for these two eclipses that are coming up. So why don't let's pop over to Slooh, and actually I want to show this. I wanted to show this guide, the Johannes Kepler's guide. These guides I think are so great, and I think they're the least utilized part of Slooh, but I just think they're amazing. So this is all about Kepler, and it's a great way to learn about some astronomers. It's also, I think, a great place where our community could be more active. There's some astronomers missing from here. For instance, Edmund Halley's missing from here. He doesn't have his own section. So I think we need to rectify that. But anyway, these things are great. They give a lot of great information and also contributions. And then they also will link you to any quests that are related. So if you're interested in Kepler, planetary motions, man, there's a quest that is, you can pop right there to it. And well, I'm not sure what happened. Okay. I'm not sure what happened there, but we can find that quest. The link may have changed. So maybe I guess that's what happened. Anyway, I'm not sure maybe let me try it again. Nope. Okay. Yeah, it may have moved to a new location, but anyway, and then it also relates it to anything that's happening now, like the Kepler Space Telescope, which was up there looking for exoplanets. So I'm going to go ahead and pause here. This is kind of brings us to the end of our first module, covering a lot of information, certainly to prepare us for Saturday, October 14th, but also just some resources that we might use in talking about eclipses with any of our friends or anything like that. So I'm happy to hang out and have a conversation, or if y'all are tired or need to go, that's okay too. I'll be signing off in just a few minutes anyway, but if we want to chat for a little bit, that's great. Or questions, I can take some and hopefully answer them, or maybe we can figure it out together. So. Gretchen, thank you for being here and monitoring everything.
Absolutely. This is like so fascinating, and what a great start to the 4-part series. So when is the next one?
October 11th. It's just before the annular eclipse. So it's sort of, you know, another moment to just touch base before that actual eclipse. Give some more information. There'll be some more hands-on things that you can do with students, and you know, and a little bit just last minute information to get us ready, at least personally ready for that eclipse, wherever we may be.
That's very exciting. So Hank, you said you're going to be able to see it live. Where will you be at?
Probably around the 3 corners, I call it, instead of 4 corners.
3 corners. Oh,
It'll be California, Nevada, and Oregon.
Cool. Love it.
And that's a dark sky spot also. So
Oh, nice.
it's kind of an interesting, yeah. Great presentation. Thank you very much, Russ. I've seen you before a while back on some other shows, but
It's been a while
good
since
to see
I've
you
been
again.
back at Slooh. So thank you, Hank.
Yeah.
It's good to see you.
Yeah. And what is the next module going to be on?
It's more on eclipses. We'll dig a little bit more into the historical relevance. So we'll do a little bit more history. There's some interesting, you know, we'll talk about Columbus and what eclipses have to do with him. And so we'll do a little bit more history, a little bit more science. We'll dive in a little bit deeper on the orbits, and how we currently do our really detailed predictions. And
Sweet.
Again, some more stuff to prepare kids, if you're working with any kids, to help them with some models and things like that. Although models are good for adults too. So yeah.
And like Keith just said, thank you a lot. Yeah. So, and how do we get these resources? How's that you were going to share with us?
Yeah. So when you signed up for the webinar, I think you had to share your email address. So I'll be sharing them directly to your email address, probably as a Google Drive or Google folder, or just as individual files if that's what you need. So I'll reach out to you and we'll figure out what works best for you.
Awesome.
Okay.
Yeah, great show.
Thank you.
Russ.
Thank you.
Yep.
Awesome. All right. Well, thank you very much, Keith. Have a good one. Hank, thank you for being here. Thank you guys for being here. That's most important. I don't know what I would have done if it was just me. But anyway, I would have soldiered on, but it's nearly as much fun. So thank you.
yeah, it was great stuff.
You would have done a great job.
All right. Awesome. Well, thank you very much. I'm going to go ahead and sign off, Gretchen, unless you've got anything else for me.
No, we're good. We'll be same place, same bat cave on the 11th of October.
Right. 2 weeks from today. So it's sort of every 2 weeks. We'll do, and then after that, we'll do 2 more modules focused on totality. And then we'll be finished with the 4-part module, 4-part professional development modules, before Thanksgiving. So
sounds awesome.
okay, good.
Perfect.
All right.